All right, so we're talking about net ionic equations. So we know how to write formulas and balance reactions, but now we're looking at what exactly actually happens in a reaction. We don't want to worry about things if nothing happens. So the net ionic equation is looking for the net, not the gross, but only the part of the reaction that actually changes something. And we did a lab where we mixed the two chemicals together and 7 different chemicals, but we mixed them in pairs to see which ones formed a solid, which ones had a change. At the heart of this, it's all about writing formulas and predicting products. Okay, so we've got example number 1 here is silver nitrate and potassium chromate. So we're going to start with just the balanced chemical equation. We have silver nitrate. It's a metal and a polyatomic ion. That means it's ionic, and it's +1 and -1, so our formula is AgNO3. And it's being mixed with potassium chromate, CrO4. You've probably not seen that, but it's on your periodic table. It's +1 and -2, so the formula is K2CrO4. Okay, those are our two reactants. Well, I've got two reactants, and they're both ionic. That means it's a double replacement, so I'm going to take these two negative things and switch their places. I'm going to leave the metals where they are, and I'm going to switch these, the anions, the negative things. I'm going to bring the chromate over to the silver, and I'm going to take the nitrate over to the potassium. Still got to find the states of matter, and it's +1 for the silver and -2 for the chromate, so 2 and 1. It doesn't matter that there was only one silver in silver nitrate. That's because that's what the charges allow. Chromate is -2, so it requires 2 silvers to balance it. +1 for the potassium, -1 for the nitrate. So that's our reaction there. So we now need to balance. And again, it's starting at the left and just systematically moving across. On the left of the arrow in the reactants, I have 1 silver, but I have 2 in the right. I can't have ended with 2 if I didn't start with 2. I move on to the nitrates. I have 2 nitrates, so I must have ended with 2 nitrates. 2 potassiums, 1 chromate, 1 chromate. So it's balanced with a 2, 1, 1, and 2. All right, so this is what we did, and we've already tested over this. Just your ability to write formulas, predict products, write them, and then make it mathematically balanced. Now it's up to finding what has actually changed. And remember, that involved finding whether things had changed their state. So we'll start with, we need to find what the state of matter for all of these things are. Well, we're just going to follow the flow chart, start with question 1 and move on down. Question 1 is one of the ions, and we'll do it, you have to do it for every single compound. This is silver nitrate. Is there a hydrogen ion in there? So is there an H plus in there? And it's no. Is there a group 1 metal? And that's sodium, lithium, potassium, rubidium, cesium, and francium. And the answer is no. Is ammonium NH4 plus 1? And no. Is acetate or nitrate? Remember, nitrate is NO3, acetate is C2H3O2 minus 1, or nitrite is NO2. And your answer is yes. So this is aqueous. Move on to the next one, potassium chromate. Is there hydrogen in there? Hydrogen ion? No. Is it one of the group 1 metals? Yeah, one of the group 1 metals is potassium. So the answer is yes, this is soluble. Okay. We'll move on to silver chromate. Is there the H plus in there? No. Group 1 metal? No. Ammonium, NH4? No. Acetate or nitrate? No. There's a halogen that's fluorine, chlorine, chloride, bromide, iodide, astatide? No. Is a sulfate in the compound? No. Remember, everything is insoluble except calcium hydroxides are the exception. So this is going to be your solid. So we know something has changed. Potassium nitrate, question 1 is there's no hydrogen. This is a group 1 metal, so this is aqueous. So we have 2 aqueous things have changed into a solid compound formed in there and something else still left in aqueous. Okay, so now we're just going to take this complete balanced reaction with states of matter, and we're going to rewrite it as an ionic compound, which is what actually happens in water. We're going to break anything that's aqueous up. If it's aqueous, it gets broken up. This is solid, so it's not going to get broken up. Something has changed. We're going to leave this solid silver chromate alone. Okay, so we have 2 silvers, and it's +1 aqueous, plus 2 nitrates, -1 aqueous, plus 2 potassium atoms, ions floating around aqueous, plus a single chromate. Produces our solid, our change thing, and then this aqueous thing gets broken up into 2K + 1 aqueous plus 2 nitrate -1 aqueous. Okay, so this is what we've been doing, and we're all pretty decent at this. The complete ionic equation, or the gross ionic equation, is just rewriting that in the way that it actually occurs in water. If we're going to say it's aqueous, then we need to write it the way it really is, where the ions separate from one another. The key here is to look and see what has and what has not changed. So we're going to, just like with balancing, we're going to start at the left and move to the right. We had 2 silver ions floating around freely on the left. When you come over to the right, they're not free anymore. They are bound up in a solid compound. So we are going to keep the silver in its new solid compound. The nitrates, it's 2 of them floating around aqueous. After the reaction, they're still there. So we don't care about those. Those are our spectator ions. They don't take part in the reaction. Move to this, we have 2 potassiums floating around freely. And over here we still have 2 potassiums floating around freely. Okay? And then we'll move to the chromates. The chromates have gone from aqueous to being bound up in a solid. So that's a change. So our net ionic equation is our 2 silver +1 aqueous ions plus our 1 chromate 2- aqueous ion produces a single silver chromate solid.